So in this video we're going to introduce separation of variables, and then we'll do an example that involves an integration by parts. So separable differential equations, they're going to occur when you get a differential equation that can be written in this form. It might not be in this form to begin with, but it can be written in this form. So we have the form p of y, so some function of y times y prime, or dy dx. We want to remember that y prime and dy dx are synonyms, mathematically speaking, and so we'll get a function of y times y prime equaling a function of x, some function of x. And it's separable because if we can get it into this form, we could then multiply both sides by dx and get it in the form p of y times dy equaling q of x dx. And then to resolve it, we integrate both sides, and when we integrate both sides, we wind up with a constant of integration on both sides. So if we have this form, p of y dy dx equals q of x, we can then write it in the form p of y dy q of x dx. And when we integrate both sides, so we get p of y dy, we get a constant of integration on the left hand side, and we integrate the right hand side, q of x dx, we get a constant of integration on the right hand side as well. But if we subtract this constant of integration, sorry, that should be plus c sub 2. If we subtract that constant of integration from both sides, we get the constant minus the constant, and this just gives us another constant. So the convention is just to write a single constant, understanding that we got a constant of integration from both sides. When we solve a differential equation and we wind up with the constant of integration, the solution that we get, we call it the general solution. So here's an example. It says find the general solution, which means that our solution is going to have the constant of integration in it. We don't have enough information to find a specific value for that constant of integration. So find the general solution for this differential equation. So this differential equation, 1 plus y cubed y prime is equal to x times the sine of x. And what we want to recognize is that the y prime can be written as dy dx. So multiplying both sides by dx, we get x sine x dx on the right hand side, and we're left with 1 plus y cubed dy on the left hand side. And the idea in integration by parts is to get everything that is a function of y attached to the dy, and everything that's a function of just x attached to the dx. So right now everything with an x is with the dx, and everything with a y that's just a function of y is with the dy. So we've separated the variables into the y's and the x's, and the next step is to integrate both sides, understanding that we get a constant of integration when we do that. And the left hand side integrates quickly. The antiderivative of 1 is just y, plus the antiderivative of y cubed with respect to dy is going to be 1/4 y to the 4th power. And then on this side, what we want to recognize is that we could use an integration by parts here. If we let u equal x, then u prime is going to equal 1, and that would mean that we needed to let v prime equal sine of x. And so v is going to be the antiderivative of the sine, and the antiderivative of sine is going to be minus the cosine of x. And so then integration by parts says take the u times the v term, so that's going to be x times minus cosine x, so we get minus x cos x, and then it's going to be minus the antiderivative of the u prime times the v term, so 1 times minus cosine, so that minus will come out and make that a plus, and we'll get the antiderivative of the cosine of x dx. We have our plus c still, our constant of integration, so we wind up with y plus 1/4 y to the 4th equaling the opposite of x, cosine of x, and then integrating cosine we get plus the sine of x plus a constant of integration. So here you can see that you can't solve it for y. explicitly. So in a differential equation where we have a dy dx, the goal is to find the function y, or y of x. And in this case, we're going to have to leave the solution implicitly defined. So we've implicitly found y. We could take this one step further if we didn't want the fraction right here. If we didn't want the 1/4, we could multiply both sides by 4. So that you don't need to, but we could, right? This is 4y plus y to the 4th minus 4x cos x plus 4 sine of x, or we could leave the 4 factored off right here, and we'd get 4 times c. What we want to recognize is if we do this, I would usually stop right here, but if we did do this, we would want to recognize that 4 times c is just another constant, so we could in a sense absorb the multiplication by 4 into that constant. So we really got c sub 1 plus c sub 2 combining into some third constant, c sub 3, and then when we multiply 4 times c sub 3, we get a fourth constant. So the constants are changing, but the idea is that we still just have a constant. So again, I would stop right here, and we don't usually subscript that constant of integration.